All right, so this is on section 6.1, which is on large sample tests for a population mean. So this is a brand new chapter, brand new topic on what's called hypothesis testing. So let's go through the general procedure for hypothesis testing. So first, we collect data or a sample. And then we formed two hypotheses. So two hypotheses, H0 and H1, are formed. H0 is called the null hypothesis. Null hypothesis. And H1 is called the alternate hypothesis. So in general, H1 and H0 are opposite of each other. And subconsciously, H1 is the one we believe, and H0 is the one we want to reject. Okay, so after forming the two hypotheses, we then calculate what's called a p-value. And we can use the p-value to draw the conclusion. All right, so let's do an example. So let's sample 100 Vandy students' IQs. Okay, so you sample 100 Vandy students and measure their IQs. Let's suppose their IQs have sample mean 105 and sample standard deviation equal to 20. So now we have two conclusions possible. So the null hypothesis and the alternate hypothesis. H0 and H1. So we want to believe, because the sample mean is 105, which is above human average IQ 100. So we want to believe that many students on average are smarter than general human beings. So this is saying that many students are on average smarter. And the opposite of alternate hypothesis is null hypothesis, which claims that many students are not smarter than general public. So this could be caused by the sample happens to pick the smarter one. So we want to decide which hypothesis is more believable. So what we do next is we construct what's called a null distribution. So essentially, we're putting the null hypothesis on trial. Okay, so we're putting this hypothesis on trial, and because the sample size is 100, which is greater than 30, the central limit theorem applies. So the null distribution is a normal distribution with mean being 100 and the variance being the sample variance divided by the sample size. So this is by the central limit theorem. And this is equal to the normal distribution with mean 100 and variance is 4. So now let's graph the null distribution. So this is normal distribution with mean 100 and variance 2 squared. And our sample mean is 105. So let's draw this here. our sample mean is 105. Then the p-value is the area of this tail. So to find the area of this tail, first we have to calculate a z-score of 105. So the z-score of 105 is 105 minus the mean divided by the standard deviation, which is 2.5. So z-score is 2.5. Now we look at the z-table. So the p-value is equal to, so you look for 2.5 on the z-table. So it's 0.0062. So the fact that p-value equals to 0.0062 means that we are 0.9938 confident that the null hypothesis is false. Okay, so this is our conclusion for now.